Alright, this is a simple tutorial on physical computer identifying parts. Only thing you really need, screwdriver, and thermal paste. They're very different, many different computers. Some of them open differently. This one, just like most businesses, are actually pretty good, like the Dell computers. All you gotta do is just see this one, press down on it, then grab this other one, and you slide it out. And there, you're already inside, right? You don't have to screwdriver it open like some other ones. So we can start with the hard drive. Yeah, some of these still use hard drives because they're very cheap when it comes to space. The only thing you gotta do, see the lock, switch it, so unlock. It has arrows, right? This is what like my double ones have blue and the arrows to let you know like what to do. Right, after you do that, behind here, I'm pretty sure it's actually a CD drive. Yep, CD. I'm just gonna keep this inside, but if you wanted to, you could easily disconnect these. So you can see at the bottom, they match up. They're not double angled. You can't just do like this and then like this. There's a thing on the bottom that prevents you from doing that. If you wanted to change out the hard drive itself. Some of these new ones, you have to remove this first. Like that. Yep. There you go. Now you can lock it. This specific one does have a thing where I just put the cable so you're able to slide through, slide out. Yeah, you can see it there. The thing on top is actually the cooler. This is really important. Unlike our Chromebooks, they have fans because they're actually kind of decently powered, so they generate a lot of heat, so you need to dissipate it. Remove this one first. I think those are probably the anchor. Next, you just remove this screw. There's a hidden screw behind here. These are a little bit crowded. And there's a final screw up right there. They're at the bottom. These are the screws connected to the black parts, not the silver ones. But it's good, right? So you got rid of, oh, this is a 2-part cooler. I don't see a lot of coolers like this. Most of the coolers on the market are just 1 part. What does it say here too? All right, there we go. This is the fan, just spins. That's what blows the air. It has this part, but it just directs the air to go outside the case because that's where you ventilate. The silver part itself is actually the heatsink. This is really important because if you just put a fan on top of the CPU, you're just kind of just blowing air into it. But it's not really that effective because you're not really pulling air away from the CPU. You're just pushing at it, which just means it'll get on the motherboard. And it doesn't cool that well. The heatsink allows for the CPU to push the heat into the sink, right? In the name sink. And then the fans can blow on the heatsink. And since it's a larger surface area, it'll do it more quickly. It's dissipating, get directed out, won't get the computer hot. It means the computer can run at a higher wattage for more power. So now to get rid of these, this is what connects to the heatsink itself. You need to remove this in order to access the CPU itself. Let me open up the rest. I think if I open all of them up, it'll just lift. That's good. That's good. There's also a water version. So instead of air, you can get water cooling, like a car. They usually reserved for like really, really high-powered CPUs. There's some CPUs that pull 400 watts an hour. So they get really hot really fast. They have huge heat sinks, water pumps, AIOs, or custom. They're also very silent because if you try to get a humongous fan, it'll get really, really loud. It's like an AC. But if you have water cooling, it's a lot quieter. Like I thought, you just gotta unscrew them like all together. Or, yeah, there you go. See that? See that in the center? You can disconnect the fan. Alright, there you go. Let me get that screw out. See that on the CPU itself? It's covered in a paste. This is what we call the thermal paste. There's very different kinds, very different brands. I'm going to clean this off and apply a new one because if you take it off, basically, CPUs, they look flat. The problem, however, is the fact that even though machines are very precise, they are not precise to the nanometer. If you search up videos of CPUs measured under like nanometer, like microscopes, you can start seeing like, even computer programs can start seeing like, oh, it's not actually flat. There's like spikes and valleys that don't make it perfectly flat. Even though to our eyes and our feeling it's flat, there are spikes because it's not perfect. So because of this, these small gaps, air gaps, they basically make it harder for the CPU to be able to push the air into the heatsink. This is not good because it means it cannot dissipate the heat as well, so it can also overheat without it. Once you put in good thermal paste, the temperatures can just drop, which allows for way more power. So the thermal paste itself, because it's a paste, it's liquidy. Most of them are not runny, but they're thick enough to where as you push it, it'll fill in all the gaps. It's like Play-Doh. If you push Play-Doh into your hands, you'll feel it. Pushes it together, so there's no air gaps, and so the air can dissipate more easily. The heat. Thermal paste, right in the name, thermal, temperature, paste. Technically it's called compound, but we call it paste. It is way better conducting heat than air. I mean, I'm sure you could see this where like, I mean, if you're cooking something in a kitchen, the house will get hot, but eventually. Most of the heat will stay in the oven. But if you feel like a metal, all of a sudden the heat travels to the metal really fast. Same thing with thermal paste. It allows the heat to transfer faster into the heat sink, allowing for better dissipation of air. Not sponsored by Arctic, not sponsored by anything, just use these because I like them. So to clean it, some of them, like Arctic, are nice enough to provide you a cleaner with a mix. But if you were to not to have that, you could probably find an alternative like Scott's Shop Original Multi-Purpose, the blue shop paper. It works just as well. Just gotta wipe it. This is old actually. This might be old, it might not be well applied. So by me reapplying it, it might actually improve the computer's performance. None of these are like super crazy computers. If you were to buy a computer from like a friend or a shop pre-built, they may use cheaper Thermal paste, if you apply to yourself, it might actually improve the performance by quite a bit, especially on laptops. Just wipe it off. The reason you want to use these, and you don't want to use normal paper towels, is because normal paper towels actually have fibers, and those fibers can actually stay on the computer and can cause issues with thermal because, again, paper towels are not as efficient at conducting heat than as compared to like thermal paste. It's like air. You don't want to have any fibers in there. I didn't do the best job. There's thermal paste on the edges. Not a huge issue. Thermal paste, it's not electrically conductive. So if thermal paste gets a little bit around the edges on the motherboard, it won't hurt it. Just don't overdo it, it won't hurt it. Unlike another type called liquid metal, but those are conductive. Those can mess up your computer if you apply too much. CPU, it's the brain of the computer. Basically, any instruction it has zeros and ones, mathematics, the CPU does it. And a bunch of threads. It does large jobs. But these are lidded down. So I think on this type, yeah, you just push down. Delidding the cover, right? We're not deleting the CPU itself. So yeah, pull this up. I'm actually interested in what kind this is. Oh, this is LGA. You see right here? There are no pins right here. These are all flat. But on the motherboard itself are the pins. Those are the pins. Be careful with the pins. Do not bend them. So because this is an Intel CPU, these aren't as bad. There's no pins there. But still, you want to be careful with the middle part. If you damage those, the computer might not turn on. The pins, you connected the CPU to the motherboard. Yeah, thermal paste also smells a little different. It's not a bad smell. You'll know when you do one yourself. Let's see what kind of CPU it is. I think you guys in the video can see it. It says Intel Core i5 8400 with a 2.8 gigahertz. This is a little bit older. 8400s are a very old model. Most of an LGA, I don't know what exactly is the model. Most of these have, you see the arrow in the CPU? That basically tells you where to put it. So on this specific motherboard model, there's an arrow right there. It's white. Different motherboards, they'll show you an arrow that basically tells you where to put the CPU. So if you're worried about, oh, what if I place it the wrong way? Just pay attention to the arrows. They'll tell you where to put it. Most motherboards have that nowadays. Now to put it in, you want to gently, right where the arrow is. All right, so now you got to do, right, is put it back. You put the latch back on. Get this part. Basically, the latch just keeps the CPU connected with the pins. Otherwise, it's a little bit loose. Also helps to get the the heat sink in. As long as it's centered enough, you really don't have to worry about it being perfect. It'll center it for you. You push it down. See that latch connects it. This is to be able to access the RAM that's under there. Right, it is covered by the hard drive. Conveniently enough. Oh, yeah, that's what that is. Yeah, because you can remove the... This is like the AIO. USBs, headphone jack. Right, you got the power button. Optiplex 3060. There should be a number somewhere. It's right next to the Dell logo. BNO628. That's the motherboard type. You can search it up to see the specs. What it has, everything that comes with it. These are stubborn. Let's get rid of these. Get rid of this. Alright, there we go. You just gotta wiggle it. I got this the other side. Sometimes it can be a little bit stubborn. P3. This one's serial SATA, basically. SATA are the standard for modern hard drives and SATA-based SSDs. You got the newest standard. CD drives are really not that common to come across. Business-oriented computers still have CDs, but for the most part, most computers will not come with a CD player or writer. You don't have to get one yourself. See that right there, made in China and everything. 2019. After you get rid of that, now you got the naked motherboard. I have searched up the specs a little bit. I believe this runs on DDR4. It's not the newest standard anymore. The newest standard nowadays is DDR5. Price is coming down quickly. First of all, let's explain what RAM is. So basically RAM, so you have the storage, right? The hard drive or the SSDs. Those are big, long term, right? They will not corrupt very quickly. The RAM is the quicker. It's like the short-term memory. It doesn't store as much. It also is more volatile, which means there's more chance for like corruption and stuff. These will run through data way faster than an SSD can. So having a lot of it can be really good for people who like edit videos. Because you hear there's only one stick on DDR4 and older generations. By having two sticks, you basically, now you can have two processes running, right? If something has to run and another process wants to go, it can also run through the other one, which is way quicker, right? It basically doubles the speed. On DDR5, basically has the technology to where there's like a big opening and like a small opening. But basically simplicity is, because of it, you can basically run like dual channel on a single stick. Having two is still better, but it runs well, even with just one. To get rid of these, right, you see these, you gotta click these open. So if you ever repair a computer, do not try to yank out the RAM without like clicking these, because you might break something. But yeah, that's basically the RAM. 16 gigabyte. The 2R/8 tells me this might come from a dual kit. So maybe they bought a dual kit, then split them up in ones for cost cutting. So this probably runs on 8, not 16. These are also not double ways. You can't just put it this way and then this way. It's really easy to tell. These have a black marker. But you want to be careful, right? I don't have carpet. But if you have corp, you want to be careful to not get static electricity. Though it's not that dangerous. If you touch a part that's really dangerous on the CPU, which is why I handle these parts on the edges, because if you have static electricity and you touch an important part of the computer, you can make it not work because you just overpowered it with your own power. It's not usually a worry. Some people who are really scared about that, they'll have like a wristband, they'll connect it to the power supply and then turn it on so that the static energy can always dissipate. Those cost extra money though. If you don't want to do that, you don't have to. Yeah, you can see that perfectly. The divider. That basically will tell you before you put it down. Oh, this is the wrong way. way. Okay, it's the other way. This is how they want it. So all you gotta do is put it back in, just align it, you'll know, and then just push it in. Some people are surprised by the on force you need to put on the RAM, but don't be scared to break it. If you've aligned it correctly, and as long as you're not pressing it unevenly, it will click. Let's go over some of the more interesting parts. Serial port. Those are very business oriented. Most home computers don't really use serial ports. They're used for networking. Next, this is 2 PCIe lanes. See those black bars? 2 PCIe lanes. Basically, these are PCIe lanes. They're like a type of way to send data to the computer. This big one has more lanes, which would allow you to put big cards, GPUs, or like SSDs are extremely fast with cooling on it. Graphics cards, in terms of what they do, graphics cards are the abbreviation of the CPU. They come after it, right? So CPUs are able to do graphics processing, but they're not very good at it because CPUs are very oriented in the way that they have a few threads and they're extremely fast, right? You have 2.8 gigahertz, they are extremely fast at those few threads. GPUs have thousands of cores. Because they have so many cores, they're not very fast cores. They are very they run in the millihertz. Together they run in gigahertz, but they run in millihertz. But because there's so many cores, you can have 1 million processes running. It's like the CPU is like a giant hands. There's not a lot of them, but it can hold a lot of things and do it really quickly. GPUs are very tiny. They're like the fingers, many tiny fingers. They cannot hold very much, but together they do a lot. You can handle many different tasks at the same time. For graphics processing, because it's a lot of small math, it's not very big math. Like the graphics on a computer, they're more efficient at that, which is how we get advanced graphics. If you wanted to, you could also put like a sound card or even like a network card, a NIC, right? Intel thing. This has a LAN. If you're using an Ethernet port, right, a bunch of Ethernet ports, basically allow you to connect, which allows for a hardwired internet. Versus wireless, it just has a little bit more delay. There's not a huge difference. Most people use wireless. It works well. It's not as clunky. So you can put a card in here to make it wireless. I'm pretty sure this probably already is wireless anyways. You probably wouldn't need that. So not to get too advanced, but basically routers, they have 2 of them. Because one can be a LAN to connect to the internet, and the other one can be a WAN, or like wide access, which basically allows the computer itself to be the router. Routers are just computers. See that right there. It's back there so you can see it probably too. Basically, most computers have them. I'm pretty sure these ones are actually removable and you can put them back. All you gotta do is, snap that open. Oh, this has a cover on it too. I think you can put them back. Basically, you can pull this out because to get the ports through, you'd be able to put wires in, but you would need this to be open. So if they stick out, it would need to be able to stick out. They are closed by default because, well, if they don't need to be open, why have it open? But yeah, just put that back. Inside this, you can probably read it right here. That is the power supply. Max output 200 watts. Most power supplies run at 500, 600, because computers do use a lot of power, so you should put a graphics card in there. This probably wouldn't actually be able to fit a very high-powered graphics card, because it would probably just blow up the power supply, because yes, they have a limit. You can plug it into the wall, because these have many cables inside them. You'd have to disassemble this. Oh, this is the actual AIO shield. See the ports themselves, just like an actual motherboard. They look nice. These use a different kind of screw. There are screws right there. This is the thing itself to plug in the power supply. I'm gonna put the AIO shield back on. One of the points of it is to rinse the motherboard from being bumped into. Now we can flip it on its side. Yeah, editing, I'm definitely gonna cut out some of these parts where it's just slow, because I think the recording is getting to like 40 minutes. I don't think anybody wants to sit through a 40-minute video. So I think with that, you can now just slide it out. And then there's cables at the bottom of there. Those are zip tied. I think this is as most as I can pull it out. So all you gotta do right now, just slide it back, push it back down. Okay, there you go. It's the thing in the back I have to pull back. There you go. You can see right there, there is a zip ties. Right, I'm not gonna try to break those because I have to put them back. I don't have those white cable ties. I'm not sure how Dell runs, but I know some companies, if you try to repair their stuff, they'll be funny with you, being like, oh, but you tampered with the computer, so therefore you cannot repair it. Which is fair, but also there's a wide discussion on whether you should be allowed to repair your own stuff, or if companies should have a monopoly. Well, at this point, explore the most parts of the computer. See that right there, that cable that runs through. Right here, this goes to CPU power. Right, yep, CPU ATX. Oh, this is ATX motherboard. There are different kinds of motherboards. You have ATX, MATX, Micro ATX. Basically, they're just the size of the motherboard. If you go to MATX or Micro or like ITX, it just means that it's smaller, more compact. So if you want a really tiny computer, you can have like small ITX motherboards. They have way less features though because they're smaller. So if you want more features, you get a bigger one. So the smaller ones do cost more though, because it is harder to cram everything in, especially if you're trying to get more features on a tiny motherboard. All right, now it's just time to reassemble the computer. As to where you place the RAM, it really doesn't matter. You can place it on this one too. It wouldn't make a difference. On motherboards with 4 RAM slots, you would have to make sure the RAM slots are like the same, in the same sides, like same, so they can run dual channel. Otherwise, they'll just run like 2 single channels and it won't be as efficient. This one only has 2, or once it's just 1, doesn't matter. or like 4 RAMs themselves. So P3, this is the P4. All right, so this is to the CD drive, the CD reader, what it is. This is the ICT. Just so you guys see them. PC4, ICT. Thing that sticks out at the top. I think you might be able to see it. Yep. Basically, they make it not two-way. Just to make sure that they align, you don't want to use it too forceful. You never do anything forcefully. Make sure it's aligned. But once you're confident, then you can put in some force. Because just like the RAM, sometimes just need a lot of force. Even the CPU sometimes needs some force to get the latch down. This one's really soft. You don't need a lot of force, but some of them you got really pushed down. So you got to trust yourself. It could be a little scary. Yeah, if you're doing this for your first time, it could definitely be a little bit daunting. I remember my first time building my own personal computer. I dedicated the entire day to it. But as you do it over time, like I'm doing, you start speeding up, you start getting used to it. And then make sure that latch right here, those things at the top. In fact, let me show you that. Yep, those would need aligned to these spikes at the top. Yeah, this thing. Yep, there you go, push down. Motherboard connects to the case. Motherboard just allows the entire computer to communicate with each other. Also, that long rant about the thermal paste, that basically just because some people don't really realize that they need it, or sometimes they forget. When you buy a new heatsink, make sure, they usually have a plastic cover just to protect it, right? Just to make sure it's clean. Make sure to take it off before you put it into the CPU, because some people can forget that, and plastic also doesn't conduct heat very well. It's like the CD drive, you gotta plug it into the right place. Points down, points down. There are 2 cables. One is the data cable. I currently have forgotten which one's the data cable, but I mean, you have to have both anyways. If you don't have both connected, it won't do anything. One is the data cable. One allows the hard drive or the SSD to be able to read and write data. The other one's the power. It's what allows the drive to have power. Yeah, it's a lot easier to work with when you take off the shield, this thing. So you can see these tabs. These basically latch on to the computer case. Yeah, these latches. So once I pull this up, you should be able to see the latches. Like this, attach the bottom ones and the top ones, and it fits perfectly. Alright, we got to this part. Reapplying the thermal paste. Still more to learn. So when you reapply the thermal paste, it depends on the kind of CPU. Older CPUs are square like this. So all you gotta do, take this off. You usually gotta protect it. These have these just to make sure it doesn't dry out, otherwise the thermal paste will dry out. You don't want that. So take it off. Push it at the top. That's what allows it to come out. All you need on these kind of CPUs is just, you need like a dot size. Some people say like a rice. I put in a good amount. Basically, it's enough to switch. You don't want to put a lot. You don't want to cover the entire thing with thermal paste because then it'll just squish all over the place and it'll just be messy, even if it doesn't destroy it. But that's enough. Once you squish it down, it'll cover basically the entire die. The delidding. Yeah, when I was talking about delidding, you can delid the CPU itself. I will not be doing that because when you do that, manufacturers will know and they will basically revoke any kind of warranty because they'll be like, hey, you just delidded the CPU. Because they don't like when you do that. Because you can do direct die cooling, which can make it even more efficient, but there are risks to that. That is like high level professional stuff. All right, now you just put the thermal. I believe this is, yeah, this is omnidirectional. It doesn't matter which way I put it. Light it up. Yeah, they're 4. You don't gotta worry about pushing the thing down. Especially once you put in the fans and stuff, it'll squish it. I'm not gonna take it off to show you because if I take it off, they'll reapply it again, and I'm not just gonna waste. But usually, if you've applied it well enough, like when you benchmark it, you'll see the temperatures are good. You don't gotta tighten it too much. As long as you tighten it enough, so don't like destroy your case or your motherboard trying to tighten it like a supreme amount. It's probably good the way you have it. At the top part, you might not be able to read it too well, but I will show you that it's there. Fan CPU. So most ports will have an indicator, especially nowadays. They're telling you where stuff goes. Like, this is the fan CPU. This is for the other fans. This is for your RGB. Basically guiding you where to put your cables so you're not in the dark. So just push it down. If I put it like this, it just won't cool anything. Lines, right? You see that? Actually, let me take that off so you guys can see it. You see those wrench-looking things sticking out next to the... See that right there? Yep, those align with these. I did it wrong. All right. There we go. I missed a step. This goes first, and then this goes. It was probably this way, huh? Yeah, it was probably, yeah, this looks right. This looks right. It's supposed to be this way, not this way. Oh, yeah, that goes in well. That gets in well. This is the screw. Yeah. Those are the power supply. Just got to make sure to put those back and not forget. If you're getting frustrated, you can maybe bump the motherboard with your screwdriver, which is not good, but most of the times it shouldn't cause damage. I think that's as good as the fan is going to get. I believe it always wiggled though, if I go back to the beginning. We'll do a segment talking about right to repair, because I do actually believe in people's abilities to repair things. Because while that's not directly related to this video specifically, I think it's important. I don't think this said F on it. So at least on Intel CPUs, if they have an F on it, it means they've disabled or gotten rid of the graphics processing unit, which means you need a discrete one. They are cheaper because, well, there's less computer, so they tend to be cheaper. But because if you don't have a graphics card, the computer will basically not boot up because you can't process any graphics. Non-F means that, hey, the computer has a graphics card. You don't need a discrete one, though if you have a discrete one, it will run faster because it has its own power, its own everything. It will be quicker. K means unlocked. That is very advanced. Basically, if it's a K, it means it's the computer. So normal computers have their boundaries, right? The software, the firmware will not let you push the computer to super fast speeds or high wattage or voltage. If it's unlocked, it will let you do that. If you destroy the computer, that's on you. But for advanced people, they may use that to like get extra performance out of it. It also allows you to lower down the parameters, which can actually be really good. If you lower down the power, you may find the computer can run the same, and you'll just be conserving power, it won't generate as much heat. It's good for the environment. The K limits, they're there because basically the computer manufacturer has decided that, hey, if you push it beyond the K limits, the CPU will run a little bit faster, but in terms of trading, in terms of wattage, it will not be very efficient. It'll go faster, but you use a little bit faster, but you use way more power, and well, that's not good, right? It's not very good for the environment, so I will give that as a plus for most CPU companies. They do care about the environment at least a little bit. Most desktops are actually pretty nice when it comes to repairing. If you're working on MacBooks, God bless you, because they put 3 million different types of screws on MacBooks. Not to say MacBooks are bad, they are really good. Most people use them. They're good for travel. Apple does a good job. But when it comes to repairing them, you can search it up. It's crazy hard. The reason it's crazy hard is actually there's no good reason. It's just hard. They made it hard, right? I'll keep talking about that later. I'm just gonna put this on. You got everything in. Ooh, before I forget, let's screw that in. 1 and a 2 and a 3. Just so the power supply isn't loose. Or power supply unit is its full name. Alright, there you go. Now the computer. Oh, this is Windows 11. That is interesting. This might have had a lockdown mechanism. However, if you put it in enough. That's probably why this computer was so easy to open. There was a lock mechanism here that doesn't exist. I was very, very surprised to see that it was very easy to open. I was like, why does it open like that? Usually, it's a little bit of effort. Alright. The point is, it's here. If I were to plug it in, it should turn on just fine. In fact, I think I have it up. And there you go. I'm gonna turn on this computer just as a check to, basically let everybody know that, hey, I've put this back together. The computer still worked when it was in my hands. You do need this because of the fact that this power supply runs like this. See that blue thing? Oh, it has a display port. Oh yeah, yep. So HDMI, display port. These are two different standards. Honestly, there's not necessarily one that's better than the other. It keeps changing. Because there's actual competition. If you have the best cable, it'll run the best quality and have the most features. So this runs on this. I'm gonna put in display port because this is the one I have available. This way. Let's switch the display. I'm not sure if the microphone can pick it up. I'm not sure if it picked it up, but the fans are on. So now if I switch to the display port, input source, display port. There you go. It's running. It is in fact running. It was good in my hands. Okay, you won't see it, but time delay not set. Please set up keyboard not found. Yep, I didn't put a keyboard on there. I'm gonna leave it like this. I believe this might be a brand new computer. I think that's why that is showing up. The time of day not set. They trusted me with a brand new computer. It has the service tag, it has the BIOS, it has everything. But this computer, point is, it worked in my hands. Alright, now I'm gonna switch it back. Now I will get on my spiel about right to repair. So there is a complicated movement basically where today many companies, right? Now companies have gotten better on this, but you still have companies like Apple who are notorious for making it extremely hard to repair their systems because they will put in many different types of screws. They start putting stuff like, hey, your part is not genuine. Hey, your battery is not genuine. Genuine. So they may put special firmware on it just so it tells them like whether the part is genuine. This genuine it's not really a thing. If it runs together, it works. Genuine doesn't really matter, right? I guess in the sense of like you don't want to buy a fake CPU, I guess, but like if it's a legitimate part, it should work together. But they purposely do stuff like, hey, it has to be genuine by making it to drive up the cost of repairing. Hey, you have to buy this part from Apple, so Apple gets to mark you up because they have a monopoly on that part. Or maybe charge you to a point where it's better for you to just buy a new phone. It's cheaper to buy a new phone. Why repair it if you could just buy a new one? It's very scummy. That kind of practice should end. That's why you have right to repair movements. You have legislators who actually have put in, laws to make sure, hey, you have the right to repair your own things. Hey, Apple, you should try not to just be exorbitantly hard to repair your products or even other companies. That is my short spiel about it. You notice here that a lot of the parts here were also removable, right? I could remove many of these parts. In laptops, not all parts are very removable. they would, what we call sodden, paste it directly onto the motherboard. That has an advantage for the fact that because it's directly on the motherboard, it is quicker. However, because it's directly connected to the motherboard, if you wanted to change it, you'd have to like literally like melt parts of it to be able to get parts out and swap it back in. Even then, it might not work. It's not standardized. You might have the best of the moment, but you're gonna have to buy a whole new one, and it's way more expensive. One thing I will add, you do not see any of this in this recording for this computer. Some companies will do things like they will put stickers on their products. If you return it to the manufacturer, they will know that you tried to tamper with it. Like I said, it has legitimate uses, right? You don't want people just randomly breaking your product, but also makes it harder for things to be repaired because, hey, if you try to repair it, now it's on you for the cost if you try to send it back to the company. And you can't use your warranty.